Hey, my name is Lakshay, and today I'm going to be going over Data Science 3.1 Comp 3122, our assignment 1. So first we're going to import everything, all our libraries that we're going to use, pandas, numpy, matplotlib. We're going to convert our CVS into an array that's readable. So I printed the head to get a general understanding, and we extract the age column into its own variable called ages. Then we have to compute for like mean, medium, standard deviation, min, and max. Mean is pretty self-explanatory. I used info to get the number of entries, which was, I believe, 18. Yeah. But you could also use len. We set total 0, and we just iteratively go through the ages column, add them up in the total, divide by 18, you get your average. Median, we just use, we create a new variable, we use ages, and we use sort values, we ascend them, so we're sorting them ascendingly. Because this is an even number, there are going to be two values that are in the middle, so we got our first number. I guess this could be our first number. It doesn't matter. You're just going to get your number, subtract by 1. That's your first number. Second number is just 18 divided by 2. And then you just add them up and divide them by 2. You get the average, which is going to be your median. Then standard deviation. This was a bit tricky to understand, but essentially you're just adding all the ages from the initial one minus mu and your square root, squaring them. Using online help, I found that if we set summation to 0 similar to total, we're just getting the total of all the ages from I to n, which is going to be our n value is going to be essentially 18, because that's how many entries we have. So we're going to do that. We're going to minus it by the mean, which is the average, which is also mu, and we square it. Then standard, this is just doing the inverse of standard deviation, so we get rid of the square root, and while doing that we get standard deviation. Minimum, we just use the ilog function. We go into the first part of the ages column, and then we just iterate through it. If it's smaller than the current age that we have, then we plug that as the minimum age. Otherwise, we continue until we're done. Opposite for max, we go to the first index of the age column. We look if we set it as our max age. If the next age is bigger, we set that as our max age. Otherwise, we continue until it's done. And you could see all the things we got over here. Then the methods, this is self-explanatory. We are just using numpy methods, mean, medium, standard deviation, min, max, percentile. So we're specifying we're going into ages, and we want the percentile for 30%, below 30%, and below 70. Creating a histogram and labeling it, creating vertical lines, and calculating how many data points. So we create a histogram of this. I labeled it age distribution by me. X label is age, Y label is frequency. Using this function, we could plot these vertical lines to find our mean, medium, mode. Because we already had mean, medium, percentile all over here, we could just use that. Just different colors for color parameter. Line style, just giving you a dash line instead of straight line. It's kind of easier on the eyes. And we're just labeling it to mean, medium for our legend later, which just shows up right here. Then percentile below 30, we go through ages. We see if it's below our 30th percentile. If it is, we count it. And if it isn't, we don't. Then we do the count divided by the total entries times 100. We get the percentile below below 30. We do the same thing for 70, and we get those values over here. And in total, the percentile should add to 100, and they do. That means we're correct. Going into question 5, we have biostats, broadcasting. Essentially, we get the numpy array because we haven't done that before, and we just multiply the whole array by this to get it in meters and this to get it in kilograms, and we find the BMI given the formula up above. Z-score is essentially scaling this and normalizing it. Scaling meaning making sure it's on the same like scale, like 0 to 1 or negative 1 to 1. So if we have a feature like weight, which is a lot bigger compared to height, weight you could have something like 60, 70, but height you could have it in like, I don't know, 1 meter, 2 meters. That's max most likely. You want it on the same scale so one feature doesn't throw off the other while we're trying to compute. And we just do that here. Then we have the indexing. We indexed everything using the map, and we made masks. So we got the sexes column because we hadn't gotten them before. Create a mask for ages under 18 or equal. Create a mask for female sexes and that are under 30, and an overweight one. If your BMI is under 25, that's the classification for overweight. You are good. And then, or only problem I kind of ran into was, I think due to this being categorical data, we had to convert it to numerical. I had some trouble doing that. So essentially we're just finding like the sum mean of the BMI, sum again medium of the BMI under females under 30. The sum, this is just to get the percentage, and the mean of the total group that are overweight. The problem that we ran into was that females under 30 are 0 and BMI under is not a number. This is because this is categorical data. We probably need to convert this to a numerical data, probably like, I think we talked about in class hot encoding it to like 0 or 1. Last question is, we randomly split the data using scikit-learn. First, we reshape this. I believe this is just transforming, just another way to transform. And then we have all our training data, testing data for x, y, and we split it. So it's going to split by 0.2 because we have a 80-20 split. Random state 0 meaning our state is always the same state. We're not going to have like different data. That's just better for us. Then we just use the scikit-learn function. We call it in and we fit it on our training data, and we compared, we set our predictions to y predictions, and then we get the mean squared, the squared error and the mean squared error. This essentially tells us if we're getting close to, and like how far our data is, like this point would be from the line of regression or line of best fit, like on average how far it is to our actual data, and then we just plot it. So we had a figure, we used the scatter graph to show all the different data points, made it in blue, linear lines based just to show the different lines, and we plot them and just set the title and everything. But yeah, thanks for watching.